Okay, good morning. Welcome to
FamilyMath709a.
FamilyMath709a. So today we're going to talk about counting paths. So if we had someone in that square and they were walking to that square, should have Lego figures to do this, but didn't think about it. And they're going to walk from this point on a grid to this point on a grid, but they can only go right and up.
So they always have to go toward their goal.
Essentially, yeah, that's probably a good way of thinking about it. But most importantly is they can't go like in loops or right, like you said, they can't go backwards over there. So we're just talking. That's right. So this is similar to a problem that both of you had on your idea math homework this week. So how do you think about a problem like this?
Well, so any path of this form is going to consist of 4 moves across and 3 moves up, just in any order.
Okay.
Yeah. So the moves gonna consist of 7 spaces, and you can choose where the cross moves are gonna go.
Okay.
So it's 7, choose 4, and then these 3 will fit in.
Yeah.
Where you didn't choose.
Okay. So draw me an example of a path.
So, like, to an over, up, over, up, and over.
Okay.
To 1, 2, 3, 4, and 1, 2, 3.
Okay. Very good. That's an interesting way to think about it using choosing numbers. Is there a different way to think about it? Do you know a different way to think about it?
Well, you could think about it like you could count the number of rights and ups you do, so 4 and 3. And then you could choose the order. You could choose the order they're going in. So you could, like, if you had rights and ups, you could choose right, up, right, up, right. So like that, you could choose how many different possibilities you have for each slot here. So this might be the same as choosing numbers way.
Yeah, because you're choosing. Yeah. So that's the same or a similar way anyway.
Yeah.
But I was wondering if there's a totally different way. What is 7 choose 4, by the way?
It's you have 7 things and you're choosing 4 of
So it's
them.
7 times 6 times 5 times 4 over 4 times 3 times 2 times 1.
Okay. Wait, what did you say it was?
7 times 6 times 5 times 4 over 4 times 3 times 2 times 1.
Oh, okay. Yeah.
Which is, so the 4's cancel, and the 6 cancels, so that's just 35.
35. So we're trying to. There are 35 paths.
Well, I think I see another way we
I
could
see
do
another
this.
way too.
Oh, you do?
So,
Okay.
So we could say you can rate how many ways there are to get to certain crossing points. So from the start, there's one way to get to this point, one way to get to this point. But since you can come at this point from these 2 ways, there's 2 ways. Then all the way up this side. So for all of these, there's only 1. So now for something like this point, what you do is you add. So you look at the ways you can get to it and you add numbers from the points that were like just previously after. So in this case it would be 3.
Okay, why do you add those previous points?
Well, because those are the ways to get to that point. You're just adding on in one section so that that'll stay the same.
And so you come from to get here. You have to come from here or come from here. There's two ways to come from here, and one way to come from there.
Right. So you're looking at the only way you can get to this point here is if you came through there or you came through there. Okay.
So then you can just fill in this whole map. So it'd be 4 for that, 5 for that. For this point, it would be 3. It would be 6. 10, 15, 4, 10, 20, and then 20 plus 15 is 35.
Cool. All right. So we can think about it with choosing numbers, or we can think about it in this path counting procedure, and it's sort of actually a surprise that those get the same answer.
Yeah.
All right. So let's move to a new problem.